Hello, and welcome to Build a Company in a Day, a session packed with demonstrations that highlight just how easy it is for companies to take advantage of Azure and begin operating at the speed of cloud. I'm Azure Dan, and over the course of this session, it's my hope that I can show you why I'm so passionate about Azure and why it should be top of mind for every IT professional. We'll begin by understanding the components of the cloud before building out infrastructure and platform services. Finally, we will wrap up by understanding how our resources are being protected and the insights that you can obtain from our extensive monitoring solutions. If you want to follow along, then feel free. Simply head over to the URL on screen and sign up for an Azure trial. Ready? Let's begin. Now, most people have heard of the cloud. Many use it, but what is it? Well, in reality, it's just a type of service where individuals and businesses rely on a third party to manage their data and computer processing via the internet. Perhaps a more practical way to think of it is as a utility. Just as gas and electricity are supplied to businesses and homes, public cloud providers supply secure, reliable and scalable computing from a shared data center that we simply plug into. What's more, with 38 regions serving over 140 countries, the cloud empowers companies to run faster and cheaper than ever before, simply paying for the resources they consume and bursting in scale when needed. At Microsoft, we place high priority on a geographic expansion that enables the highest performance and data residency. And with a unified code base running both publicly and privately via services such as Azure Stack, we can partner with organizations and enterprises worldwide and create a densely populated offering. Today, startups, governments and enterprises of all sizes choose the Microsoft Cloud and its comprehensive set of services to build, deploy and manage workloads with integrated tools, DevOps solutions and marketplace offerings. All of which aid in building anything from simple mobile applications to large-scale internet solutions. And the exciting thing is, this wave of innovation continues to gain momentum, with changes happening almost daily. It's an IT professional's dream come true, a digital playground that enables us to rethink, repackage and create innovative solutions that maximize efficiency while fortifying security. Now we're going to jump into a demo of the portal in a few moments. But before we do, let's understand the service tiers on offer. To do so, we first need to understand how things are done on premises. Building IT solutions is likened to building a tower with blocks. We stack one service upon the other until we reach our goal, always ensuring that the block below is stable and secure before placing the next. And just like the game, the higher the blocks stand, the harder they become to manage. In a classic on-premises IT solution, we would buy powerful servers to host our virtual machines, which in turn would run our applications. And while this was the norm, we can see that the bit that matters, providing our users and customers with great application experiences, was in fact a very small piece of the puzzle. By moving our solutions over to a cloud provider, we can reduce management, with companies such as Microsoft undertaking the responsibility of the underpinning resources. Take IaaS, or Infrastructure as a Service, for example. Now, IaaS is perfect for migrating solutions already in place over to the cloud and is often referred to as lift and shift. With IaaS, you simply port your virtual machines into the cloud and allow Microsoft to look after the physical resources whilst you concentrate on the operating system and the applications that run upon them. For new projects, PaaS, or Platform as a Service, would be first choice. With this tier, you can become laser focused on what matters, the customer and great service experiences, instructing the cloud provider to manage all resources and reliability tasks while giving you total peace of mind that your solutions are highly available and globally scalable should you need. Finally, we have SaaS, or Software as a Service, a collection of pre-packaged IT solutions that we can simply subscribe to. Think Office 365, Outlook, OneDrive, even Xbox Live. With these solutions, we can maximize the power of the cloud without ever having to consider the resources needed to power the solution. Now, Microsoft offer a whole catalogue of services within the Azure portfolio, and we're going to see just how many of them we can use in our presentation today. But before we do, let's familiarize ourselves with the portal and navigating around both the graphical and command line interfaces. So if you've used Azure in the past, you may have used it via the Azure Service Manager Portal, or ASM for short. ASM was often referred to as the classic interface, but has now been replaced with Azure Resource Manager. ARM allows you to view and manage all resources in one unified hub, be that through the rich graphical experience or the integrated command line via the Cloud Shell. With ARM, you have a single, easy to use console built just for you, significantly simplifying building, deploying and managing your cloud resources. What's more, you can organise the portal to custom fit your work style and stay on top of the things that matter most by pinning them to your dashboard and selecting the right amount of detail and insights across your apps and resources. So let's go ahead and make some customizations. Now, I personally prefer the default colour scheme, so I will keep it as is. But what I want to do is clean up our dashboard, rename and add a logo. Cleaning up the dashboard is as simple as clicking on a tile and choosing to unpin or resize. Let's remove all pin tiles for now and then rename our dashboard to Build a Company in a Day. Now let's add our markdown. To do this, I will move over to the left hand side and under Tile Gallery, drag the Markdown tile over to the main window. As we can see, this opens a side blade whereby we can create custom content. We'll add our logo by replacing the code to point to an online storage account where I've uploaded the image. With that done, let's go ahead and finish customizing. Now to the left hand side of the portal, you'll see a list of resources which again can be totally customized. To do so, simply click on all services at the top of the list, followed by the services that you wish to pin or remove from the sidebar. You can rearrange the order by dragging them around or even minimize the menu by clicking the left arrows icon at the top of page. Now, over the course of the session, we'll use the portal extensively, demonstrating just how user-friendly it is. But if you're a seasoned IT pro who prefers a command line interface, then those tools are at your disposal too. If I move towards the top of page, you can see that I can launch a Cloud Shell, which will then allow me to build out resources using either Bash or PowerShell. You'll notice that when I launch this for the first time, I'm prompted to create some resources. This is for persistent session information and means that my experience remains consistent. Once configured, my Cloud Shell environment will build, allowing me to create resources using a command line. I can even navigate to its own portal at shell.azure.com and do away with the graphical portal altogether should I choose. We'll make use of the Cloud Shell throughout the session, but before we do, I just want to cover one more thing: resource groups. You see, everything that we build in Azure will ultimately live inside a resource group, and what's more, by bunching services together, we're able to control access, management and billing. Resource groups are super easy to create. We can simply click on resource groups on our sidebar or use the keyboard shortcut G and R. From there we can click on add and then provide a name, select a subscription and define a location. Let's go ahead and call ours IaaS Resources and place it into the West Europe region. Once created, let's go ahead and click into the resource group. Now, I appreciate that we currently have no resources inside the group, but what we can see is that on the left hand side we have a number of options. From here we can look at activity logs and identity and access management, we can look at resource costs, we can even set policies to specify what can and what can't be created inside the group. We can also generate an automation script that can be used to redeploy resources at a later stage or onto a different subscription altogether. Finally, we can monitor metrics, set up alerts, and gain valuable insight into our resources. So now we have a better understanding of the portal. Let's begin building out our services. To begin with, we'll concentrate on infrastructure as a service and use the tools available to build our compute components. We'll concentrate on the network and our addressing schemes, and then connectivity into Azure before building out some virtual machines using an array of deployment methods. Once done, we'll understand what the deal is with containers and why they have become so popular before building out our directory and ensuring that we provide secure authentication into our system. Finally, we will look at deploying a DevTest Lab and investigate how we can sandbox testing environments with granular cost control before protecting everything that we have created with Azure's powerful backup solutions. Let's begin by understanding the virtual network. Now, the virtual network allows us to define our address space, or the numbering system that we are going to use that would allow our computers and resources to talk to each other. Similar to a residential address in which houses share a postcode yet separated by a door number, a virtual network achieves the same in the cloud by defining network and host IDs. The first thing that we will need to do is decide what our address space will be, and in this instance we will choose the value 192.168.10.0 with a /24-bit mask. What this means is out of the 32 bits used for the address space, the first 24 will be used to identify the network or our postcode, leaving the remaining 8 to identify the host. This gives us a potential for 256 possible addresses. Now, 256 isn't a particularly big number, especially in large organisations, but do bear in mind that these numbers can be changed to support millions of hosts. We are just keeping it simple to help with the learning. Out of these 256 values, I want to further subdivide. I want to reserve some addresses for my production machines, perhaps reserve some for development, and finally reserve some to route traffic across the network should I choose to communicate with remote hosts. To do this, we will create subnets, and these are created by borrowing bits from the host to create little groupings of resources. And this is important because once grouped together, I can then control the flow of information between them, ensuring that my front end and back end servers only communicate with the nodes that they are supposed to. But what if I want to communicate with resources that are in a completely different network altogether? Thankfully with Azure this is super easy, and we can create peerings between virtual networks which then route traffic through the Microsoft backbone and allow them to appear as one. Not only is this incredibly fast with low latency, high bandwidth connections, but because it's on Microsoft's own private network and not routed through the public internet, you can also be assured that it's highly secure. Finally, we have many options available to allow networks outside the scope of the Microsoft Cloud to communicate with our resources. For on-premises machines, we can create site-to-site virtual private networks and tunnel traffic securely over the internet. Or we can create our own private connections with technologies such as ExpressRoute. For individuals, we can create point-to-site connections that allow remote users secure access into our cloud resources. To achieve this, we need to create a gateway, which will take on the responsibility of moving the data between the cloud and the recipient, much like the postman moves mail between the postcodes in our earlier example. So let's now jump back into the portal and start building this out. Earlier, we created our resource group, IaaS Resources, and we'll be using that to host the components that we're about to create. So from our desktop, let's go ahead and click on Resource Groups from the left-hand menu and then IaaS Resources. Once inside the resource group, we'll click on Add. Now this will take us into the Marketplace, our online store for provisioning services. From here, all we need to do is simply type Virtual Network inside the search box. Now you will see that the search box will fetch lots of results, but only one will be called Virtual Network. So let's go ahead and select that. As you'll see, this opens up a new blade and invites us to select a deployment model, either Classic or Resource Manager. But as we said earlier, we'll only be concentrating on Resource Manager in our demo. So we'll click the Create button, which opens up another new blade. And from here, we'll need to complete the questions to proceed. To begin with, we'll name our virtual network Build a Company in a Day VNet. Then, as we said earlier in the video, we'll set our address space to 192.168.10.0/24. From here, we will select our subscription and ensure that the virtual network will be in the existing IaaS resource group. We also want to then set a subnet name to production and address range to 192.168.10.0/25. Finally, we'll want to ensure that we select Pin to Dashboard before pressing the Create button. And that's it. The service will be deployed, which should take less than a minute to complete. Now, once completed, you'll notice that the portal displays our newly deployed resource. From here, we can further configure by adding some new subnets, which we'll use later in the demo. To achieve this, we'll move down to the section titled Settings and select Subnets. From here, you'll notice our production subnet listed and the available addresses, in addition to two buttons, one called Subnet and one called Gateway Subnet. If we click on the Subnet button, let's go ahead and add a new subnet called Development. From there, we will set an address range to 192.168.10.128/26, which will give us a total of 59 usable address spaces. We can also see that we can set the network security group, the root table, and service endpoints. With that created, let's now create our gateway subnet. Now, this will be used to route traffic between the Microsoft Cloud and a remote location, so we'll need to ensure that this is configured correctly for routing to occur. Fortunately, Azure will do most of the work for us, and all we need to do is click the OK button. Brilliant! Our virtual network and subnets are all configured, and we are now in a position where we can start hosting resources in our network. But before we do, we need to deploy our gateway server so that our remote machines can securely connect. So back into our IaaS resource group, let's go ahead and click on Add to go into the marketplace. And from there, what we will do is we will search for a virtual network gateway. From here, let's select Virtual Network Gateway from the results and then go ahead and click Create. Now, for our name, we'll call our gateway Build a Company in a Day GW and ensure that the gateway type is set to root-based VPN. For the SKU, we'll select the basic tier. Now, when we click on Choose a Virtual Network, we should see that we're able to select our Build a Company in a Day VNet that we created earlier. Then we can go ahead and create a public address, which we will again name Build a Company in a Day Gateway. Finally, we will ensure that the resource group and location are correct before selecting the Pin to Dashboard checkbox and hitting the Create button. At this point, our gateway will be provisioned. Now, be patient, this could take a while, but rest assured we have lots to keep us occupied whilst it builds, and we'll need to think about how we will authenticate into the gateway once it has. Now, authenticating into our gateway will be achieved using certificates. This means that we will need to generate both a client and root certificate in order for communication to occur. To do this, we will run the PowerShell script Build a Company in a Day search NPS1, which automatically creates the certificates required to authenticate with the gateway. Now, we can't upload the certificate directly into Azure, so we need to extract its thumbprint. To do this, I will open up the certificate from Notepad and copy the signature between the Begin Certificate and End Certificate tags into my clipboard. Then, with my gateway created, I will click on the point to site configuration found under settings and then configure now. From here I will specify an address pool of 192.168.20.0/28, as well as enter our certificate thumbprint that we copied from Notepad. We'll name the certificate Build a Company in a Day root, and once done, press save on the top menu bar. Now this will take a few moments, but once saved, you'll notice that we are able to download the VPN client from the Azure Portal. So let's go ahead and do that. From here you will notice that you have a 32-bit and 64-bit client. We'll go ahead and install the 64-bit version. Now don't be surprised to see a Windows protected your PC message. This is because we are installing an executable from the internet and Windows is trying to protect us. Rest assured the file is perfectly safe, so let's go ahead and choose to run anyway. Once installed, you'll notice that we now have a Build a Company in a Day VNet connection in our network connections. If we click onto it, we're able to connect and authenticate into our Azure Gateway. To prove this, let's open up a command prompt and type the command ipconfig. You'll notice the adapter PPP adapter Build a Company in a Day VNet, which has an address space of 192.168.20.2 from the range that we specified earlier. We now have secure access into the cloud, so let's move on and start building out our virtual machines. Now the number of compute sizes available in Azure can at times seem a little daunting, especially when you're trying to work out which one you should choose to support your workload. To make life a little simpler, Microsoft have defined 6 service categories that are aimed at specific workloads. First, we have the general purpose machines with a balanced CPU to memory ratio, and ideal for testing and development. Then we have the compute optimized configuration, which is perfect for running medium traffic web servers, network appliances, batch processes and application servers. Next, we have the memory optimized configuration, which is great for relational database servers and in-memory analytics. Moving on, we have the storage optimized configuration, tailored to meet the demands of big data, SQL and NoSQL databases. Then, the GPU optimized configuration, which is targeted for heavy graphic rendering and video editing. And finally, the high performance compute configuration, which are purpose built for maximum performance and lightning fast throughput. Again, don't try to remember all of the numbers. Just think about the workload that you're trying to support and then refer to the sizing tools and calculators available on azure.com. Another thing to bear in mind is that Azure isn't just a Windows platform. In fact, nearly half of all of the virtual machines created in the Microsoft Cloud are running Linux. So with that in mind, let me try and show you a few different ways to deploy virtual machines. To begin with, we'll create a domain controller, and we're going to do this by creating an ARM template. Now, ARM templates are sometimes referred to as infrastructure as code, and are a simple way of deploying resources quickly and repeatedly. The main benefit of using ARM templates are that they allow you to deploy multiple resources at the same time. And although they look a little scary to begin with, when we look under the covers, we can see that what we are really doing is declaring the types of resources that we would like to have, the name we would like to give them, and any properties that should be associated with them. Let's take a better look. So from our portal, we will head up to the search bar, and from here I'm going to search for templates. Once in, I will click on Add, And then in the general blade, enter the name Build a Company in a Day DC, followed by a description. And the description we will type is this ARM template will create a domain controller virtual machine connected to the Build a Company in a Day VNet. Once done, I will click OK, and then in the ARM template box, I will replace the code with a script that I've previously created. Again, I appreciate that this looks a little daunting, but let's try and break it down. To begin with, we have the schema. Now the schema is the rules of the template. It defines what the template must look like, how we extract information from it, and how Azure interacts with the code. Next, we have the parameters, and we can see that these define things such as the name we would like the resources to have, the network we would like it to be on, and so on. These are the questions that the user will be asked when they deploy the template, but as you can see, we're also able to pre-populate these parameters with default values, making deployment even easier for the end user. Next, we have the variables. Now, variables store values that can be used multiple times throughout the template, and because they're hard-coded, they require no input from the end user. Finally, we have our resources, or the types of objects that we wish to deploy. In this case, a virtual machine, some storage, an operating system, a network card. So now we have a better idea of the template, let's go ahead and copy and paste into Azure. Now I just need to select OK, followed by Add. And once our template has been validated and saved, we'll go ahead and hit refresh. And then we can go and deploy. Now to do this, I'm just going to click on the ellipse and choose to deploy. And we'll see that as this opens, as we stated before, most of our values have been pre-populated with the default entries. All I need to do is choose my existing resource group, IaaS resources, and then scroll down to accept the license agreement, pin to dashboard, and then click purchase. Now once validation has occurred, Azure will begin deploying this template into our subscription. So the next thing that we're going to do is we're going to look at deploying a virtual machine using a marketplace image. So to do this, I'm going to move over to the left-hand menu and choose to create a resource. And from here, I'm going to search for a Visual Studio Community Edition on Windows Server 2016. So let's select that and then hit create. And then from there, we'll go ahead and give it the name VM1. We'll opt to use a standard hard disk for our image, and I'll type in a username of Build a Company in a Day admin, followed by a password. Next, we'll choose to use an existing resource group and select IaaS resources before pressing OK. In the next section, we will choose a D2 V3 standard VM. This will give us 2 CPUs and 8 GB of RAM. In our next section, we need to define our settings. The first setting will be our availability set. Now, availability sets are a good idea to provide redundancy in our application and are therefore recommended for production workloads. This configuration ensures that during planned or unplanned maintenance events, at least one of our machines will be available and meets the 99.95 Azure SLA. In our demo environment, however, we will skip this stage and move on. For storage, we will want to use managed disks. Now, managed disks are relatively new and take away the burden of the administrator having to create a separate storage account and worry about availability and redundancy. By selecting a managed disk, Azure will undertake these steps for you. Next we will come down to network, and we can see both the virtual network and the subnet have been pre-populated with the settings that we created earlier. This is because Azure realizes that the components share the same resource group and therefore suggests them as default values. Nothing to change here, so let's skip to the public IP address. The public IP address is our public connection to the outside world, and you could argue that because we already have a private connection via our point-to-site gateway, this step could be omitted. However, for our demo we will configure a static address and then configure a network security group to allow RDP traffic through public interface TCP port 3389. Next we come down to extensions, and from here we can add features such as antivirus protection and desired state configurations into our deployment. Let's go ahead and select Microsoft Anti-Malware. On the new blade that opens, we will press Create and then OK to accept the defaults for protection. Then we will press OK once more to close the extensions window. Now we need to decide whether we want to configure an auto shutdown policy. From here we have the options of specifying a time slot to automatically shut down our virtual machine and whether we wish to send a notification before doing so. For the sake of our demo, I'm going to choose to leave this setting switched to off. Moving on, we now have the option of specifying whether we want to monitor boot and guest OS diagnostics. These will be particularly useful for gaining insights into the condition of the machine and enabling alerts via the core metrics. Let's set both to yes, and you'll notice that by doing so we are prompted to configure a storage account to hold the diagnostic information. Once done, we can press OK and then OK once more to move on to the final section. This displays a summary of our configuration and validates that our inputs are correct. From here we can see a breakdown of the components selected, the hourly cost. We can also download the configuration as a template or choose to deploy the resource into production. Let's press the Create button to deploy. So this will take a little while to provision, so let's pause the video while our virtual machines deploy. So with our Windows-based virtual machines created, let's take a look at how we can connect. We'll begin by clicking on the pin tile for ADVM. Now when this opens, it will default to the Overview tab. From here we can see general information such as the machine's status, the resource group that it is being deployed into, and the operating system that it's running. As we move down the tile, we can see basic metrics for the machine, including CPU, network and disk performance, and we can toggle these counters anywhere between an hour and 30 days. At the top of the blade you will notice that we're able to start, stop, restart, move and delete the virtual machine. You'll also notice an option to connect by using the public IP address that we created earlier. If we click on the button, an RDP profile will download, allowing us to connect into our VM. Because we also have a private connection into our VM, we're also able to connect securely via our gateway. To do this, all we need to find is our private IP address. To do this, let's move over to the left hand side and under Settings, click onto the Networking tab. This will change the main window, and from here we should be able to see the private IP address listed, which in this instance is 192.168.10.4. With our address at hand, let's open a remote desktop connection and connect into the IP address of ADVM. When prompted, we will enter the username, build a company in a day admin and the password, and then in the certificate warning window, click yes to authenticate into the machine. Awesome. Now we will come back to the configuration of the machine later, but notice that when the Server Manager window opens, the machine has indeed been configured as a domain controller on the Builder Company domain. So let's now close our RDP session and go back into the settings of our virtual machine. You'll notice that on the left hand menu we can add additional disks, additional extensions and many other components. But some of the more important aspects are to ensure that we keep our VM up to date with the latest security patches and updates. Remember, infrastructure as a service means it's your responsibility to make your VM secure. Thankfully, Azure makes this incredibly easy with update management, which uses log analytics and automation accounts to streamline the whole process. Once enabled, it could take up to 15 minutes to provision, so we'll pause the video and return once completed. Okay, so we can see that 3 missing updates have been identified, meaning that our machine is not in compliance. So let's go ahead and schedule an update deployment. To do so, I will click onto the Scheduled Update Deployments tab. From here, I will name my scheduled update AD VM Update and then move down the blade. Now you will notice that I'm able to exclude certain updates. This may be down to testing or incompatibility. Remember, you are in the driving seat. We're just making the process as simple as possible. Under Schedule Settings, we can configure when the update deployment starts and whether it's a reoccurring thing. For our demo, we will schedule to start in 30 minutes from now and leave it to a single instance. Finally, I will leave the maintenance window to the default 2 hours to ensure enough time for the updates to install. Okay, let's pause the video once more and we will return once the updates have completed. And we're back. And we can see that our update's deployed, but we've experienced a failure at some point. Let's look at the tools and investigate. Now if I click onto the Update Deployments tab, I can see a status of failed for my current scheduled task. I can gain more insight as to what may have gone wrong by clicking into it. As we can see, the majority of the installs have succeeded, but the definition update for Windows Defender failed. By looking at the updates, we can also see that Windows Defender was installing an update for the platform at the time, which may have contributed to the error. We can reschedule the failed update for another install, but for the sake of time, let's move on. Now another area of importance is inventory and change management. By using these tools, you can get great visibility into installed applications and custom defined configurations through rich reporting and search capability. Both will not only focus on software, but also registry, services and file changes, making it a fantastic tool for monitoring baseline security policies. As we can see, change tracking has identified the changes invoked by update management, providing a rich audit log. If we move down to the monitoring section, we can consume telemetry to gain visibility into the performance and health of our workloads. Furthermore, we can track the performance of a resource, in this instance a VM, by plotting its metrics onto the portal chart and pinning it to the dashboard. We're also able to be notified of any issue that impacts the performance of our resource by configuring alerts and then action those through automation. Moving on, if we select the advisor, we are assisted by a personalized cloud consultant designed to help optimize deployments. This is done by analyzing resource configuration and using telemetry, and then recommending solutions to help improve the performance, security, and high availability of our resources while looking for opportunities to reduce overall cloud spend. If we click onto diagram, we get an exploded view of our resource. What's more, the components are hyperlinked, allowing you to navigate directly to the associated configuration blades if needed. Finally, under support and troubleshooting, we can see that we're able to assess Azure Resource Health, which aids in helping you diagnose and get support when Azure service problems affect your resources. It informs you about the current and past health of your resources and provides technical support to help you mitigate problems. We are also able to view Azure VM boot diagnostics to capture logs that can help troubleshoot boot failures and obtain screenshots to see the VM's current state, as well as reset the password of forgotten machine accounts. If need be, we can redeploy an Azure virtual machine to a new node if we've experienced difficulty connecting. When we redeploy, Azure moves the VM to a new node within the Azure infrastructure and then powers it back on, retaining all of your configuration options and associated resources. Finally, if all else fails, we're able to generate a support request directly from the portal and streamline directly into the right support area. Now with our final machine, we're going to deploy a CentOS image, and I'm delighted to be joined by Justin Davis, one of our technology solution professionals who has kindly agreed to show us just how easy this is achieved by using the Azure Cloud Shell. Justin, over to you.
Thanks, Dan. But before I jump into the Cloud Shell, I just want to spend a little bit of time talking about open source and Microsoft's 4 pillars of work. Firstly, we've enabled the Azure platform to run Linux within the Hyper-V hypervisor, and Linux Integration Services, or LIS for short, enables Linux to run as efficiently as possible on our data center servers. On top of this, we ensure that you can bring programming languages from the open source world into our PaaS offerings, including languages such as PHP, Node.js, Python, and many others. The second pillar is the integration of open source projects into the Azure platform. Projects such as HD Insights, which utilize the Hortonworks distribution, or Azure Container Services built upon Kubernetes. In all cases, we manage the environment, meaning that all you need to worry about are the applications you wish to deploy. The third pillar, and perhaps one of the most telling displays of our commitment to an open source ideology, is the pace at which we release our own software into the open source community. We've taken services such as .NET Core, PowerShell, and Microsoft Cognitive Toolkit into the open and actively work with the open source community to drive innovation and fix issues raised through GitHub. Finally, and underpinning our commitment to open source foundations, we are members of the Linux Foundation, Cloud Foundry Foundation, as well as the Cloud Native Foundation. This allows us to listen to the community and contribute back as part of that. So that's an overview of Microsoft and open source. Now let's start looking at how that fits with Azure and have a look at the Cloud Shell. The Cloud Shell is an embedded Linux VM that is accessible over the web. This is really useful when you don't have full internet access because of firewall policies, but also comes with a few extra benefits. The Azure command line is pre-installed and authenticated against your Azure accounts. This will be a familiar interface for Linux administrators and allow you to script actions that need to be repeatable. So let's take a look at the Cloud Shell and deploy some machines. To begin with, we'll navigate to the top of the menu bar and press the Cloud Shell button. The Cloud Shell's got some pretty great features built in above and beyond the Azure command line. Firstly, if you're a Terraform kind of person, the command line is already there in the shell and fully authenticated and ready to work with your default subscription. If you're an Ansible or Cloud Foundry kind of person, we already have those command lines installed and ready for you to use too. There's nothing you really need to do here, just clicking on the Cloud Shell icon will load it up for you and you're good to go. We can see we have the Daniel at Azure command line. I can issue usual Linux commands if I want to, but here I'm going to create a default CentOS VM. But before we do that, we need to ensure that we're able to securely authenticate to the machine. We'll do this by creating a digital certificate very similar to the one that Dan created earlier on, and I do this by typing SSH-keygen into the command line interface and simply press enter on the subsequent prompts. Once we're completed, we have all the components needed to build our virtual machine. To do so, we're going to type in quite a long command line, and I'll run through that with you in a second. So let's copy and paste that. Great, so we have it pasted into the command line. Let's just run through what's going on here. So we're using the AZ command to be able to issue commands against the API with the VM, and we're going to use the create option as well. We're going to use -n VM2 to be able to give it the name. -g IaaS resources is the name of the resource group we want this VM to be loaded into that Dan created earlier on. And then we have the image that we actually want to create as well. So in this case, we're using CentOS, but you can use Red Hat Enterprise or SUSE if you wanted to, or any other Linux distribution or Windows. We also want to add the admin username, so the super user that I want to automatically create on the virtual machines for me, allows me to be able to come root, for example. And then the SSH key that we just created previously as well. So everything we did just now, we're actually going to push that up to the virtual machine. The network security group we want to actually create and name, and the subnet, the production subnet, and the build a company in a day VNet that Dan created earlier on is where we want this VM to be placed. Next, we want to be able to create the instance, or to be able to choose the instance we want to use. Dan talked about those previously. You can choose any of those instances that you want when you're using the command line shell as well. And then finally, it's the public IP address, or the name of the public IP address that we want to add into this machine. So let's go ahead and press return here. And we're just going to pause this for a second because you don't want to sit here watching a blinking cursor for the next 5 minutes. And then we have the virtual machine created for us. You can see that we have the public IP address, which has been given to us by Azure, and the private IP address range, which came from the subnet as well. If you don't remember the IP address or don't copy and paste it down, then we can actually use the Azure command line to be able to find out what that public IP address is. Well, this is actually coming useful in a second after one of the commands that we run. So azvm list IP addresses -n for the virtual machine name that we just created, and also the resource group as well, to allow the command to be able to find the virtual machine within any number of resource groups that you have. We're going to use -o table because by default the Azure command line also spits out data in JSON format. Table is a lot easier to be able to use. Right, well, because we're now going to be creating a web server in this virtual machine, we actually need to allow HTTP traffic or port 80 traffic through. This is the port used for web traffic and needed for the web service role that we'll put in the machine in a few moments. To open the port, we'll type the command line azvm open port -g for the resource group that the VM is within, and -n vm2, which is the name of the virtual machine that we created. We also need to specify the port that we wish to open, and then also the priority as well. So -- priority. So if we had a number of rules within those NSGs, as Dan talks about later on, then the priority that we give to it will either be higher or lower than existing NSG rules. So the Azure command line is now talking to the Azure API and is asking to be able to open the port. That's come back. And now, as you can see, we've lost the IP address that we had. So we just use list IP addresses. Let's take that IP address now and use it to be able to SSH into the virtual machine. So the admin user that we created earlier on has already been created on the machine for us. Let's paste the IP address. And what you see when you first log into this machine is the security warning that the trust relationship hasn't been established yet. Hit yes, and then that machine will be trusted from the Azure command line shell and for the target machine as well. So now we just have a standard Linux virtual machine which is running CentOS. What we now need to be able to do is to be able to install HTTPD or Apache, because I'm old school, I like Apache as a web server, and also we're going to use Git as well to be able to check out the code for Dan's website. So let's go ahead and as sudo, becoming root, do sudo yum install httpd git. So once we've got that, hit return. What will happen is that those packages will now be downloaded for us and be installed. It takes a little bit of time. We hit yes. We're all good to go for those packages to be installed for us. And now we have Apache and Git installed and all of the dependencies there. So now that we have all of the services installed that we need to, we're just going to check out Dan's website from my GitHub repository. So git clone http github.com/JustinDavis/BACIAD for Build a Company in a Day. So that's all been downloaded for us. We need to go into that directory and we need to just copy those over into var www HTML. Oh, I just need to make sure that's a recursive copy. Let's go back. -R, return. Great. So everything's copied over there now. Now that everything's installed, we need to start Apache. So HTTP start. Oh, I need to do this as root. So let's Control-C that. So sudo service HTTP start. Great. So Apache is now running for us. And also, if the machine gets rebooted, we need to make sure that the system comes back up and HTTPD is running as well. So systemctl enable HTTPD, press return. Great. So it's all good and ready to go. Now let's take that IP address, go to the web browser, and let's see if Dan's site is up and running for us. And there's the man himself. So we now have Dan's website running on a CentOS OS, running as IaaS on Azure.
So we've deployed 3 different machines by using 3 different methods, and it's my hope that you're beginning to see just how diverse this product is. Remember, you are in the driving seat and you work with the tools and utilities that are right for you. But let's now shift focus and move on to our next section, containers.
Thanks, Dan. To help us understand a little better, let's think about the traditional software delivery process. You see, in the past, you'd design an application and from there would have to consider the operating system and all its dependencies. And while this was fine on a developer's machine, problems would typically arise when you tried to run that code on another. Containers solve this problem by not only hosting the application, but the complete runtime environment, meaning that all libraries, binaries, and configuration files are bundled into one package, much like that of a zip file. These are not to be confused with virtual machines, which virtualize the hardware and the operating system before running the application. Containers should only contain the bare minimum to function, which means they can be a lot smaller than a standard OS deployment. What this means is because of the reduced overhead, the container host can run many more containers than it ever could with a virtual machine. Containers offer consistency between development and production and allow you to go through the development cycle with a lot less risk. This in turn increases the speed to deploy into production, meaning you can react faster to the requirement changes in your applications. Long gone are the monolithic designs and long waits. Containers allow the hard work to be taken care of for you, allowing you to concentrate on good, quality applications. For example, if you cast your minds back a few years, IT had a very different culture. Companies would order the tin, wait for delivery, and then deploy code. The process was slow, cumbersome, and typically ran as a single solution. The ability to scale those solutions meant buying bigger machines, or if you were lucky, more instances to scale out. That is, of course, if your applications were designed to be distributed. The lack of agility meant it unfeasible to break up services. But today, with containers, applications can be divided into smaller, more manageable chunks, meaning that the updates can be made to one service without having to update the entire system. Let's jump into a demo and take a look. Microsoft has really embraced containers across a large swathe of the Azure ecosystem. I'll come on to containers later, but for now, there's a really nice offering we have called Azure Container Instances, or ACI. Container instances are a way for you to tell Azure, I want to run something in a container, give me an IP address and some CPU, memory and storage, and I'll be happy. So let's take a look at our site from before, but let's deploy it as a container instance. If we go back to the Cloud Shell, we can do this pretty quickly. So we use AZ group create -n build a company in a day -ACI. So this is a resource group that we're going to use to actually deploy our containers into. That comes back really quickly. And then we're going to use the AZ container command line to deploy the Docker image. So AZ container create -n, we're going to give it a name, so build a company in a day, -g, the resource group that we just created, and then we need to give it the Docker image that we want to deploy as well. So the same image that we used before, Azure Dan /doc repo, build a company in a day. And then we want to basically make sure that it has an IP address attached to it. So we're going to say we want a public IP address attached onto this container. Let's go for that. And we have the container coming back now. So let's take a look at the IP address that's been assigned to it. And here we have so there's Dan's site up and running again from a container. So that's brilliant. That's a very easy way to be able to get a single container up into the cloud very quickly. Now we're moving up the levels of responsibility here. We've deployed a Linux virtual machine, deployed a web app onto it, and now we've done the same thing with containers too. The level of management you need to be able to deploy your systems is greatly reduced. It's great you can deploy a single container to Azure and get it up and running really quickly, but your applications or site relies on multiple components or containers. You need something to orchestrate those together. As an example, if we wanted to scale our website from one instance to 10, 50, or even 100 because the amount of people viewing it has gone up, I'd need to have that container as a deployment. A deployment is a way of saying I have a container or a pod of containers that I want to scale up independently. With an orchestrator, I can define our site as a deployment unit and scale that up and down. Deploying Kubernetes from scratch is quite an involved process, and what we've done is take the best practice globally and from people that have developed Kubernetes with a simple point and click or using the Azure command line. You can deploy that, as I'll show you shortly. You can get a fully deployed cluster in a matter of minutes, and we take care of the updates, the resilience, and the scalability for you. All you have to worry about is getting your app tested and deployed quicker. So let's go back to the Cloud Shell and spin up an AKS cluster in East US and get our website up and running and scaled up. So we need to be able to create a resource group for the Azure Container Service Cluster. So AZ group create -n, build a company in a day -AKS, -L for the location. As I said, this case we're going to use East US. So that resource group has been created. And now we use the AZ command line to be able to create the AKS cluster. So AZ AKS create -n, the name of the cluster, the name we want to give the cluster, and -g, the resource group that we just created. Hit return, and what's happening now is that the command line is talking to Azure, creating a service principal for you, which allows us to be able to spin up infrastructure on your behalf, which becomes important when you're doing things like load balancer integration. And this is going to take a few minutes now, so what we're going to do is pause, and we'll come back in a second. Great, well that was quite simple. In the background, Azure was spinning up virtual machines that were running your agent workloads. Essentially anything that we deploy onto AKS will be running on these machines. It's reserving a control plane for you to be able to work with, so taking care of the management infrastructure for your Kubernetes cluster, and within the Kubernetes cluster those managers decide where to place your containers and your workloads. We essentially make that service available to you for free, and all you pay for is the container workload machines. Right, so we've got the cluster up and running. What you now need to be able to do is to be able to authenticate against the Kubernetes cluster, and we have a command line in option to be able to do this for you, which is AZ AKS get credentials. So AZ AKS get credentials -n, build a company in a day AKS, -g, build a company in a day AKS. And what's happened there is that we've downloaded the certificates for the cluster, so we are now fully authenticated. The Cloud Shell has the Kubernetes or kubectl command already baked into it, so if we just go ahead and just type that in, kubectl, we can see the command line is there and ready to go. Now that's great, but now we need a workload to be able to push up to the Kubernetes cluster. So we use the kubectl command to be able to run a Docker container directly, and we'll mess around with that and expose the services and do some scaling up now. So kubectl run, we're going to call the deployment builder company in a day. The image, -- image, is the Docker container that we've been working with already. And then we're only going to have one replica, so one version of this running at any one time. So replicas equals 1, and we're going to make sure that Kubernetes is aware that we have a service that to be exposed on port 80 within the container. So very quickly, Kubernetes has basically taken our request for that deployment and is now deploying that pod. So a pod is the lowest form of deployment that you can actually get within Kubernetes. So it's still pulling the container down, and then we have the running website there within a pod. So that's brilliant. The next thing that we need to be able to do then is to actually expose that. So to be able to publish that service into the internet. So we'll do kubectl expose deployment, build a company in a day. That was the deployment we created earlier on. We want to export on port 80. And the important thing here is the type. So type equals load balancer. This is really, oh, I've got this wrong. I'll go back up again. I'll just take the command in wrong. Minus type load balancer. So what's happening there? Oh, I've got to go back and remove the service. 1 second. kubectl delete service, build a company in a day. Okay, so go back up and let's deploy that again. There you go. So what's happening here is that Kubernetes is talking to the Azure infrastructure and spinning up a load balancer instance for us and attaching that to our pod that we've just pushed out. Now this takes a few minutes to be able to attach and to be able to spin up a load balancer, so we'll pause here. I'll come back in a second. We now have the public IP address which has been assigned. What we can do is just take that IP address, just check that the service is properly exposed for us to be able to use. Let's copy that. Open up a new tab, paste the IP address, and there he is again. So we've got Dan's website running there. Now that's great. So the whole idea is that we've just told the cluster we wanted to be able to deploy a container for us, and that's fantastic. But what about if you want to be able to scale something up or down? So let's just use kubectl scale, the number of replicas. The deployment is called build a company a day. Let's do that. Oh, sorry, I missed out the number of replicas. Let's go back. Replicas equals, let's do 3. So what's happening now is that the deployment has been scaled up from 1 instance of Dan's website into 3. Let's do it again. And we have 3 up and running. And the load balancer is now looking after all of the scalability and scaling between those 3 deployments. So there we have it. We've gone on a whistle-stop tour of open source and kind of finished with Kubernetes. And from the outside, not a lot has happened here in terms of having to hand crank virtual machines or to be able to spin anything up for Kubernetes. And we take care of all of that for you. We just want you to worry about your code and your applications that you want to be able to deploy into the cloud. So the whole idea of Kubernetes is that I am telling Kubernetes that there is a desired state that I want it to be in. In this case, the desired state initially was I want 1 version of Dan's website running. Then my desired state was to be able to have a service published for that website. And then more importantly, the desired state of having 3 of those sites running at the same time. If I have 3 physical VMs which are actually running my workload and I have a pod on each one of those virtual machines and one of those goes down, the desired state of the cluster will still remain, as in Kubernetes will try and run that on another machine, so we still have 3 versions of it running, and that's really, really powerful. So I hope that's been really interesting for you. We've explored containers and orchestration, virtual machines, and all that's left for me is to say thank you for your time. Feel free to drop me a line on Twitter @JustinDavies or send me an email to juda@microsoft.com. if you have any questions about open source and Azure. And now, Dan, it's back to you.
Now, whenever you sit in front of a computer, sign into an application or post onto your favourite social media site, you will at some point need to be authenticated. Authentication helps you keep personal information secure and ensures that users only have access to the resources that they're supposed to have access to. So let's take a few minutes to understand what authentication is and how the cloud has made us reevaluate the whole process. We'll begin by discussing directory services and the role of the domain controller. To better understand, think about what happens when we sit down in front of our work computer. Now, before you can use it, you need to log on and authenticate. Now, this may be achieved by using a username and password or a smart card and PIN, or for some it may even be achieved by using a biometric authentication method such as a fingerprint. Regardless of how it's achieved, your authentication attempt will be cross-referenced against a database to see if you can use the machine. What's more, once authenticated, you'll be given a digital token which is then presented to the resources to determine the level of permissions you should have. Now, as we move towards the cloud and the abundance of online resources, our authentication requests can start to become disjointed. Think about how many times we must log on throughout the day, especially when we are using services that are not directly controlled by our company. By using Azure Active Directory, we can effectively create a bridge between the on-premises and online resources, thus ensuring that our end users get a consistent single sign-on experience. What's more, with its full suite of identity management capabilities, including multi-factor authentication, privileged account management, and role-based access control, Azure Active Directory can help secure your cloud-based resources from online security risks while streamlining IT processes, cutting costs, and ensuring that your corporate compliance goals are met. So let's jump into a demo and look at how we can connect our domain controller into Azure AD. So back into the portal, let's go ahead and look on the left-hand side to select Azure Active Directory. And we'll see that as the blade changes focus, we're able to manage attributes such as users and groups, devices and applications, as well as set things up like custom domain names and company branding. What we want to do though is look at merging our domain controller that we created earlier with Azure Active Directory. And to do that, we will need to ensure that we create some administrative accounts for the service to use. So from the Azure Cloud Shell, I'm going to run the command AZ AD user create with a display name of Azure AD, a user principal name of Azure AD at buildacompanyinaday.onmicrosoft.com, and put in a password. With that done, I will click onto the new user, and then from the directory role section, ensure that they are a member of the global administrators group before clicking on the save button. At this point, we're done with the configuration from the cloud side, so we'll jump back into our domain controller and populate it with some accounts. Now you'll recall that earlier on we used a template to create this virtual machine. During installation, we invoked a desired state configuration tool to build this machine out as a domain controller in the Build a Company in a Day video.local domain. So let's now go ahead and open Active Directory users and computers. As we can see, this is a base build, so we're going to go ahead and populate our directory with a script. To do this, I'm going to copy the AD users folder into the VM and then open up an elevated PowerShell window. To begin with, I want to set the execution policy of the machine, so I will type the command set-execution policy unrestricted and then select yes for all when prompted. Next, I'll copy the files over to the domain controller and run the Build a Company in a Day AD user script. This will create a handful of users and a local administrative account. From here we can download the Active Directory sync tool and merge our directories together. Before we do this though, I just want to first go back into Server Manager and click onto the local server from the left hand menu and then disable the IE Enhanced security configuration for both administrators and users. Once done, I can download and run the Microsoft Azure Active Directory Connect tool. When the Microsoft Azure Active Directory Connect window opens, we will go ahead and accept the license terms and privacy notice, and then select Continue, which will open the next prompt and invite us to customize or use the express settings. Let's go ahead and select Use Express Settings. This will configure synchronization of our identities and passwords in the Build a Company in a Day video.local domain and start the initial synchronization between locations. In the next window, we will need to enter the details of our Azure AD Global Administrator, followed by the local administrator account that was added via our script. Then on the next page, we will notice a warning stating that we don't have a verified domain. Now this is fine for our demo, but obviously not fit for production due to the fact that we want to enjoy a consistent naming convention. As I said, for the sake of our demo, this is fine, so we will select continue without any verified domains and press next to continue. Once done, the service will validate and invite us to press install. Now this will take a few minutes. First, the dependencies will need to install, and then the directories will need to connect before they start the initial synchronization. However, once complete, we can exit the installation wizard and head back into the Azure Portal. Let's pause the video and come back once synchronization is completed. Okay, and we're back. And as we can see, our on-premises accounts have now populated into Azure Active Directory, giving us unified authentication. So let's look at what we can now do now that our accounts are in the cloud. To begin with, I want to talk about the different SKUs available. You see, Azure Active Directory comes in 3 flavors. These range from the basic SKU designed for task workers with cloud first needs, up until the advanced premium SKU, which includes enhanced protection through hybrid scenarios that leverage on enhanced security signaling. For our demo, we're going to activate a trial of Enterprise Mobility and Security, which includes the premium version of Azure Active Directory. To do so, let's click on Licenses from the left-hand menu, and then in the new window that opens, All Products under Manage. From the top menu bar, let's go ahead and select Try and Buy, and then select the free trial of Enterprise Mobility and Security, followed by Activate. Okay, so we now have a premium SKU in place. Let's start investigating some of its capability. Now the first thing that I want to do is reiterate the fact that we can of course add a custom domain name to Azure AD. To do so, navigate to Custom Domain Names from the left hand menu and then click on the button Add Custom Domain. From here we can enter our custom domain name, which will then require us to verify it using either a TXT or MX record. Now unfortunately I don't have a custom domain name, but the process is as simple as that to complete. Continuing with our customization theme, let's navigate down to company branding. From here I can add backgrounds and messages to my authentication screens. To do so, I will click Edit, and then from here select a new background and username hint before pressing Save. Now we will test this out in a while, but in the meantime, let's continue configuring our identity service by setting up a self-service password reset policy. To do so, I will click on Password Reset under Manage, and then in the new window that opens, select All and then Save in the Properties window. From there, I will select Authentication Methods from the left-hand menu and make note of the defaults, email or mobile phone. Now I can be more restrictive here and select multiple methods, but for our demo I'm happy with the defaults. Moving on, I will select Registration from the left hand menu and require users to register with the service when authenticating. I will also leave the reconfirmation policy to the default of 180 days. Finally, under Notifications, I will select to notify all admins when an administrative password is changed and then press Save. Now I'm going to talk about security later in our session, so the last thing that I want to demo here is enterprise applications and single sign-on to cloud-based resources. Single sign-on allows us to access all of the applications and resources that we need to do business by signing in only once and using a single user account. To put this into perspective, think about the companies that rely on applications such as Office 365, Box and Salesforce for end user productivity. Historically, IT staff needed to individually create and update user accounts in each SaaS application, and users had to remember a password for each. Azure AD extends on-premises AD into the cloud, enabling users to use their primary organisational accounts, and not only sign into their domain join devices and company resources, but also all of the web and SaaS applications needed for their job. This means that staff no longer have to manage multiple sets of usernames and passwords, and application access can be automatically provisioned or deprovisioned based on their organisational group members or status as an employee. So let's go ahead and test this with a connection to Twitter. To do so, we will select Enterprise Applications under Manage on the left-hand menu. Then, in the new window that opens, I'll click New Application, and then under Category select Social. As you can see, this changes the focus of the gallery to display social connectors, and I will filter so that it only displays Twitter. In the new blade that opens, notice the single sign-on mode. In our demo, we'll be storing the password in the cloud and then assigning single sign-on to one of our users. To continue, press the Add button at the bottom of the blade. With our application added, we are taken to a new window. From here, we can set up single sign-on into the application. To do so, select Single Sign-On under Manage, and then in the single sign-on mode, select Password-based sign-on and press Save. From the left-hand menu, select Users and Groups and then Add User. In the Add Assignments window, we will go ahead and select Azure Dan and then click Assign Credentials from the menu. In the Assign Credentials window, we'll select Yes to assign credentials on behalf of the user, and then enter the Twitter logon credentials followed by OK and Assign. You'll notice that our user is now added into the list, so let's go ahead and test this out. To do so, I will open a new session, navigate to myapps.microsoft.com and log in as Azure Dan. Now as I do this, notice the customization we added display on the screen. Also notice how I'm prompted to verify my contact information in order to proceed. Now this will take a few minutes to configure, so I will once again pause the video and return once verified. Okay, so now that I'm verified, I just need to install the My App Secure Sign-In extension into my browser. Once done, I will click onto the Twitter icon on my dashboard, and as you can see, I'm then automatically authenticated into my session. Brilliant! So we now have single sign-on across our applications, self-service password management and branded authentication experience. Let's continue with our session and build out our next solution. Now, one of the first workloads that inevitably makes its way onto the cloud is that of the development team. In the past, this would have had to have been heavily policed by admin, but thanks to new services such as DevTest Labs, developers and testers can quickly create environments in Azure while minimizing waste and controlling cost. DevTest Labs allow you to test the latest version of your application by quickly provisioning Windows and Linux environments using reusable templates and artifacts. What's more, you can easily set policies on your lab which define things such as the number of virtual machines allowed, the sizing, software, even schedules to automatically start and shut down your virtual machines. DevTest Labs enable you to create pre-provisioned environments with everything your team needs to start developing and testing workloads. Simply claim the environments where the last good build of your application is installed and get working right away. Let's jump into the portal and take a look. So the first thing we will do is navigate to the IaaS Resources resource group, and from there we will go ahead and click on Add and search for DevTest Labs in the marketplace. You'll notice that two results are filtered: Native DevTest Labs and DevTest Labs for Blockchain. This enables developers to support public, private and consortium blockchains. For our demo, we will select the standard DevTest Lab solution and then press Create button to open the configuration blade. Now we don't have a great deal to set up here. We simply need to name the lab, select our subscription, select our location, and then decide if we want to enable auto shutdown and configure tags. We'll call our lab Build a Company in a Day DevTest Lab and then accept all defaults before choosing to pin to dashboard and press Create. That'll take a couple of minutes to provision, so let's pause the video and come back when it's done. Now this resource will look a little different from the resources that we've created previously in our demo. This is because the DevTest Lab is a platform for other deployments, and in this screen what we're effectively doing is scoping out our environment. Let's take a better look. Now the first thing that I want to do is configure my secrets, which would allow me to save my passwords into a key vault that I can then use later for formulas and virtual machine creation. And this is super simple to do. All I need to do is type in a name and a value such as VM secret and then my password before pressing the save button. Next, I'm going to click on Configuration and Policies. From here I can begin to define the resource types allowed inside my DevTest Lab and place restrictions on costing and operating time. If we move down to Settings and then click Allowed Virtual Machine Sizes, we can specify the sizing tiers that will be available to our developers. Let's enable this feature, and then in the center pane go ahead and select the standard D2 V2 and standard D3 V2 virtual machines. We'll then move to the top pane and press the Save button. If we then move back to the left hand side and select virtual machines per lab, we can define the number of machines that will be allowed to be deployed and how many of those machines will be granted premium disk support. Next, I want to come down to repositories under external resources. Now I'm not actually going to configure anything here, but I just wanted to highlight that we are currently connected to a public repo, but we could easily add our own by clicking on the Add button. The repository will allow you to add custom artifacts into the lab, such as those hosted on your company's private Git repositories. Okay. One of the things that I do want to change is the virtual networks. You see, when the DevTest Lab was created, it went ahead and configured a new VNet on our behalf. But if you cast your mind back to earlier in the demo, we already have configured a development subnet, which I'd like to make use of here. So I'm going to click on the Add button, and from there I will select the Build a Company in a Day VNet under the Select Virtual Network area. You'll notice that once selected, the three subnets that we created earlier are displayed. We want to now select both Use in Virtual Machine Creation and Allow Public IP Creation options for the development subnet. We also have the option of sharing the public IP address through network address translation and specifying the maximum virtual machines allowed per user. However, these are not required for our demo, so I will go ahead and click the OK button followed by Save on the virtual network blade. With that done, let's go back to the Configuration and Policies Virtual Network section on our breadcrumb menu and then remove the Build a Company in a Day DevTest Lab Virtual Network by selecting Yes on the confirmation prompt. Okay, now while that deletes, we'll navigate to the Virtual Machine Basis section on the left hand side and select Marketplace Images. What we want to do here is specify a whitelist of images that can be used in our DevTest Lab. To configure this, we will select No in the Allow All Azure Marketplace Images, and then we're going to select the CentOS OS image and the Windows Server 2012 R2 image. Finally, I want to come down to formulas under virtual machine bases and click add to create a new one. Now a formula is a list of default property values which are used to create a VM, and you'll notice that as it invites us to choose a base, the only options that are presented to us are the marketplace images that we defined earlier. Let's go ahead and choose Windows 2012. Next we'll give our formula a name and we'll call ours Demo Server. In the description, I will place that it's going to be running a server and also have Chrome and Visual Studio installed. For the username, I will type Build a Company in a Day admin, and then for the password, go ahead and select the VM secret to retrieve our password from the key vault that we created earlier. For the disk size, I will leave as is and also keep the virtual machine to the default setting. Now here's where things get interesting. You'll notice that I'm able to select artifacts, and artifacts are what's derived from the repositories that we discussed earlier. If I go ahead and select, this displays a list of components in the public repo, and from here I want to add Chrome and Visual Studio Code before pressing the OK button. As you can see, we now have two artifacts selected, and if I now click on Advanced Settings, I'm able to choose whether this machine will automatically expire after a set time and whether it's claimable by our DevTest Lab users. I'm going to go ahead and stick with the defaults here, so I'll press the OK button followed by Create to build our formula. After a few seconds, our formula is ready. Now, this hasn't deployed any resources, it's simply created a template for when we wish to do so. Let's test this out by navigating back to the DevTest Lab and then clicking on Add in the center pane. From here, you will notice that we have three options. We can select the formula that we just created or the two marketplace images we defined earlier. I'm going to go ahead and select our formula. As the blade opens, we can see that 90% of the parameter fields have been completed, and really all we need to do is name our VM, which I'm going to call DevTest Lab VM1. From there, we will go ahead and press the Create button and our machine will deploy. Now this will take slightly longer than the VMs we've deployed earlier. This is because not only are we initiating a VM from the marketplace, we're also applying the artifacts. So let's go ahead and pause the video and we'll come back once complete. And we're back. Hopefully, if you've been following along, that took no longer than a few minutes to deploy, and we're now in a position where we can authenticate into the machine. To do so, I will click on the DevTest Lab VM1 machine in the middle pane, and from there press the Connect button to download an RDP profile. Once connected and authenticated, you'll notice that I have both Chrome and Visual Studio installed and prominent on the desktop, proving a successful formula deployment. Now before we wrap this up, I just want to show you one last thing. You see, in a development environment, you're going to want to be able to replicate workloads, and sometimes the best way to do this is via a custom image. Now custom images enable you to create VMs quickly without having to wait for all the required software to be installed on the target machine. If you think about the DevTest Lab VM1 machine that we just deployed, not only did it have to install the operating system, it also then had to download and install the artifacts. Things would be much faster if this were all on disk. Fortunately, DevTest Labs enable this to happen, and to illustrate, I'm going to create a custom image from our deployed machine. To do so, I will navigate to the left-hand menu and from there select Create Custom Image. When the blade changes focus, I would name the custom image DevTest Lab Image and then type in a description. The next thing that I will need to do is specify that sysprep has not been run on the virtual machine and that I require it to do so. You'll see that when I select Run Sysprep on the virtual machine, a notification will appear. What they're basically telling me is that sysprep will generalize my machine, meaning that everything that is unique, such as the name and security identifiers, will be destroyed in the image creation. In layman's terms, we are killing the machine so that it can be cloned and then uniquely deployed many times thereafter. So let's go ahead and accept by pressing the OK button. Again, this will take a few minutes to create, but when complete, it will appear as a new option during the machine creation. Let's go ahead and pause the video and come back once done. With the image creation complete, we'll notice that it has now become a deployment option from the Add menu. Okay, with that done, let's jump out of the portal and discuss our next technology. So let's change focus and investigate how we can protect our workload in the cloud. And I guess I want to concentrate on two areas here, Azure Backup and Azure Site Recovery. Now, Azure Backup replaces your existing on-premises or off-site backup strategies with a cloud-based solution that is reliable, secure, and cost competitive. It offers multiple connectors depending on the type of workload that you wish to protect and provides many benefits including automatic storage management, unlimited scaling, encryption, and long-term retention with a limit of 9,999 recovery points per protected instance. Backups are compressed to reduce storage space, and in certain scenarios, this deduplication is employed to ensure that file protection is fast and efficient. What's more, every backup component supports both incremental and differential backup options, ensuring time-efficient transfers are commonplace. Azure Site Recovery, on the other hand, orchestrates and manages disaster recovery policies and is a key service in helping organizations keep their data safe and workloads running when planned and unplanned outages occur. ASR replicates Azure virtual machines between Azure regions, but also on-premises VMs and physical machines, either to the cloud or a secondary physical location. Let's jump back into the demo and look at how we can use Azure Site Recovery to replicate an Azure VM. So let's begin by creating a new VM. Now, for the sake of transparency, I'm creating this VM in the East US region purely because of a limitation of the trial pass that I'm using to record this session. Nothing new to see here, so I will pause the video and we'll return when our machine has been deployed. With our machine deployed, let's select Disaster Recovery from under the Operations heading. This will in turn open up the Disaster Recovery configuration pane. Under the target region, I will ensure that East US 2 is selected. Now, when you enable Azure VM replication, the following resources will be automatically created. This includes the target resource group, network, storage accounts, and availability sets. You'll also notice a cache storage account, which is used before a source VM change is replicated to the target. This ensures minimal impact on production applications running on the source VM. Now, this will take about 20 minutes to configure, so I'll pause the video once more and we'll come back once completed. And we're back. So let's once more go into the virtual machine and then select Disaster Recovery from the left-hand menu. Now we can see that we're able to both failover and perform a test failover. So let's go ahead and click on the Test Failover button, which will open up a new blade. From here, notice how we can select the recovery point and virtual network. So we can see that we're going from East US to East US 2, and our recovery point, we're going to select the latest. And then under the Azure Virtual Network, we're going to select the one that was created when ASR was enabled. Now make note of the warning, but for our demo, this is going to be absolutely fine. So let's say OK. And once more, we'll pause the video and we'll come back once the test failover is completed. With our test failover complete, let's click on the notification to open the job summary. Now notice the stages the failover went through in creating the test VM. Now this proves that failover is operational. So let's navigate back into the disaster recovery section of our virtual machine and clean up our test failover. From here, we'll type something into our notes. And then finally opt to delete the failover virtual machine. Awesome, so we now have a disaster recovery and automatic failover configured for our virtual machine. But what about protecting the VM with backup? From the portal, we'll select the virtual machine and then backup from under the operations heading. In the blade that opens, we'll create a new recovery service vault named VM Backup and a new backup policy by accepting the defaults. When done, we'll press the OK button followed by Enable Backup. Now this will take a few minutes, but once the configuration is complete, we'll be able to test. To achieve this, let's head back into the VM blade and once again select Backup under Operations. From the blade that opens, we'll select Backup Now, accepting the default retention, and then press OK to proceed. From notifications, we'll select the triggering backup of the virtual machine notification to open up the backup jobs and notice the status of the VM. Now, this will take around 30 minutes to complete. So once more, we'll pause the video and return when done. And we're back. And we can see that our virtual machine backup is now complete. So let's perform a test restoration. To achieve this, we will once again head into the backup area of the virtual machine. In the top menu, we'll select Restore VM, and in the new blade that opens, select the last crash consistent backup. In the Restore configuration pane, we can select our restore type. From here, we can either choose to create a new virtual machine or restore disks to a staging location. For this exercise, we'll choose to create a new virtual machine. We'll name it VM Restore and keep it in the default resource group. We'll then press OK to proceed. Now once more, we'll check on the jobs notification to launch the backup jobs window. From here, we can monitor progress, which again should take around 30 minutes to complete. So, for the last time, let's pause the video and we'll come back once this is completed. Okay, we're back. Let's navigate to the Virtual Machines tab from the left hand side of the portal, where we'll notice a new running virtual machine titled VM Restore. This once again proves that our BCDR strategy has been successful and the diversity of our product. Now I appreciate that this was a long section, but with the power of video editing, we've been able to streamline this into an easy to consume segment. I invite you to further study to see how this technology can also be used to protect on-premises resources, both in a virtualized and physical state. For now, let's jump out of the portal and discuss our next technology. So up until this point, we have really concentrated on infrastructure as a service. And while I'm first to admit that we can achieve great things with what we have seen, for me, the true power of the cloud is embraced with PaaS, or Platform as a Service. I'm going to spend a little time demonstrating the power of PaaS and highlight some of my favourite tools in the Microsoft Cloud. These are the tools that I use every day, tools that allow me to run my website, automate my social media, gauge public opinion and store useful data. What's more, all of this is achieved without me having to configure a single virtual machine. I think you're really going to love this section, so let's begin. We'll begin by discussing app services. Now, app services are the umbrella name for 4 key solution areas: web apps, mobile apps, API apps, and logic apps. Let's look at each of these in turn. Web apps are a fully managed compute platform that allow you to build and host web applications in the programming language of your choice. It offers auto scaling and high availability, supports both Windows and Linux, and enables automated deployments from GitHub, Visual Studio Team Services, or any Git repository. The price you'll pay is significantly lower than running the experience on an equivalent virtual machine and largely determined by the app service plan you choose. Mobile apps provide developers with a platform that's both highly scalable and globally available. With mobile apps, you can build native, cross-platform applications for iOS, Android, and Windows that seamlessly connect into enterprise resources through single sign-on experiences. What's more, you can empower a more productive workforce by building applications that synchronize data in the background with your enterprise data sources and SaaS APIs. Finally, with push notifications, you can reach millions of people in seconds, engaging your customers with personalized messages regardless of their preferred device. Now, we mentioned APIs a moment ago, but what are they and what do they do? Well, in simple terms, an API is nothing more than a set of instructions that define how an application talks to another. Think about the times you've used a copy and paste, or when we visit a website of our favourite restaurant and see the directions supplied by a third-party mapping service. APIs make this sharing of code possible, and they do this by exposing just a little bit of the program's functions to the outside world. The Azure API service makes it easy to develop, host and consume APIs, both in the cloud and on premises. You'll get enterprise-grade security, simple access control, hybrid connectivity, and seamless integration with Logic Apps. Finally, Logic Apps. Hands down my most favourite thing in the cloud and a strong area of focus in an upcoming demo. Now, I use Logic Apps extensively, from automating my social media presence to pushing information down into my smart mirror at home. I even use them to gauge how well my presentations are received by means of sentiment analysis. And trust me, Logic Apps will change the way you think about business logic, with simple, scalable workflows that are triggered by events and able to talk with other services by means of a rich catalogue of connectors. What's more, we don't even have to start from scratch. We have many pre-existing templates ready for us to build upon. So let's jump into a demo and start building this stuff out. So the first thing that we're going to do is deploy our website. And if you cast your mind back to earlier, we've already done this a couple of times, both as a fully fledged website on Linux and then as a container solution. But what we want to do now is deploy a website as part of an Azure App Service via Visual Studio. So let's go ahead and open the website in Visual Studio and then click on index.html on the right hand side. Now you'll notice that there's not much to it. It's just a simple HTML file which is currently calling on a script to load my Twitter feed and display it on the left hand side of the page. If you want to change to your own Twitter feed, you'll just need to replace the href code with your own Twitter handle minus the @ character. So let's go ahead and run this locally so that we can make sure the code is working. To do so, we'll move towards the menu bar at the top and click on the green play button next to the name of our browser, in my case Google Chrome. The page will compile and display a prompt asking if we would like to enable debugging. Now usually this would be a great idea, however due to the simplicity of our code I think we could probably work out any issues, so we'll choose to proceed without. As you can see, the page opens and displays a backdrop with our Twitter feed on the left hand side. At this point we can close the browser and begin creating our web app. So let's jump back into the Azure Portal and from the dashboard press the key combination G+R to open the resource groups. From here we'll go ahead and click on the Add button to create a new resource group, naming it PAS Resources, confirming our subscription and choosing West Europe as our location. When ready, we'll press the Create button to deploy. Now we'll give it a second to create and then refresh the page. Once done, let's click into the resource group so we can begin building out our web app. To do so, click on the Add button on the top menu and from the Marketplace search for WebApps. You'll notice many offerings, but we will choose the native web application option, which should be top of page. When the new blade opens, we will click Create. For the app name, we need to think of something unique. This is because they are all subdomains under azurewebsites.net. Obviously, we can add our own domain name once deployed, but for now we'll give it something obscure so that we avoid any conflicts. I'll call mine Build a Company in a Day website.azurewebsites.net. I'll then check to see if I'm happy with the subscription being used and that it's being deployed into our PAS Resources resource group with an operating system running Windows. The next thing that I'm going to need to define is the app service plan. Now, an app service plan is the set of compute resources that I want to use to run my code. And just like a conventional hosting scenario, I'm able to run multiple workloads if capacity allows. And let me just take a time out here to clarify something. Earlier I said that no VMs are used in PAS. Well, to be more specific, it's no VMs that you need to manage. You see, Microsoft will look after everything, from scaling to protection, leaving you with an abstracted administration portal to define your requirements. So let's go ahead and click on the Create button. Now in the new blade, I'll name my ASP Build a Company in a Day WebASP and ensure that it's located in the West Europe region before clicking on the pricing tier. In the pricing tier blade, you'll notice that you can choose shared compute models, which in some cases will be free of charge. What's more, I can then scale to large deployments running into hundreds of pounds each month. I'm going to go ahead and select the S1 standard tier. This will give me a single dedicated core with 1.75 gigabytes of memory. What's more, it would allow me to automatically scale up to 10 instances when needed, as well as provide me with daily backups and the ability to create deployment slots which can be used for staging. From here, I will press the select button followed by OK. The last thing that we need to decide is whether we want to enable application insights. Now these will help us both detect and diagnose quality issues whilst providing better insight into how our web app is being used. For that reason, I'll set it to on and then set my application insight location to West Europe. Finally, I will choose to pin to dashboard and press the create button. Once deployed, we'll begin exploring our application options. Now in our overview pane, we have some basic insights, things like data in, data out, and average response time. Now don't be surprised if we don't have any metrics displayed. The web app has only just been created. Furthermore, we haven't yet uploaded any content to our site, so let's revisit these counters later. If I move up to the Essentials section, you'll notice we have the URL and ASP tiers, as well as a blank FTP and connection details. Let's go ahead and set that up. If I move over to the Deployment Credentials section, I can then add my FTP deployment username, Build a Company in a Day FTP, and my password. Once done, we'll press the Save button. Oops, now it looks like we have an error here because the FTP credentials are not globally unique. So let's make a small modification to the name and save again. Okay, so next I will move down to the deployment slots where I'm able to create additional staging environments. Now I don't want to spend too much time on this section at the moment as we'll be revisiting this later when we have uploaded our site. So for now, let's proceed with the demo. If I move down to the next section, deployment options, I'm able to specify the deployment source. Now this could be Visual Studio, Team Services, GitHub, or even OneDrive if I choose. For now, I'll leave the defaults and head back by using the breadcrumb menu. Next we have the application settings, and from here I'm able to configure things such as the version of .NET, PHP or Java that I wish to use. I can also decide the platform, affinities and debugging options required. Then, from authentication authorization, I'm able to define authentication services such as Azure AD, Facebook, Twitter, or anonymous authentication. For our demo, we'll want to lock down our website so that it's only available to staff, so we'll be revisiting this section once our site has been deployed. In the backup section, I can define a backup policy. So let's go ahead and click on the configure at the top of the menu bar to get this set up. In the new blade that opens, I will select Storage Settings and then press the button Storage Account to create a new backup location. I'll name the storage Build a Company in a Day website and ensure that it's unique in the .core.windows.net domain. From here, I will set the replication as locally redundant and the location to West Europe before pressing the OK button. Once deployed, I will click on the storage account, build a company in a day web, and then create a new private container named backups before pressing OK. When done, that should take us back to the backup configuration pane. From here, I will set schedule backups to on, accepting the defaults before pressing the save button. You'll now see that the pane changes once more, allowing me to both backup and restore in addition to the schedule just set. Okay, back to the left hand menu, and from here we can see that what we're able to set is both the custom domain and the SSL certificates. I'm also able to configure networking and choose whether I want to set IP restrictions, CDN endpoints, or integrate into existing virtual networks. Next, we have the option to scale up or scale out. Now remember, with a cloud mindset, it's not always about being bigger. Often it's about quantity and being clever with sizing. We have configured an app service plan that enables auto scaling, and as such, Azure can add up to 10 instances if required. Okay, let's jump down to the section titled Development Tools. Now from here we can log on to our website using the cloud-based console or even launch the app service editor. What this means is we can service our web app anywhere we have access to a browser and internet connection. What's more, with tools such as Kudu and Resource Explorer, I can gain valuable insights into my deployments when needed. We'll revisit the app service editor a little later in the demo, but for now, let's get this page deployed. To do so, I will once again click on the overview section in the left hand menu. Then from the top menu, choose Get Published Profile. What this will do is download a connection profile that we can then use to push content into the web app from Visual Studio. Once downloaded, we'll jump back into Visual Studio, and from the Solution Explorer on the right hand side, I'm going to right click our website and choose Publish Web App. In the pop-up window, I'll select the import for the published target and then browse to the download folder to find our published profile before pressing the OK button to proceed. In the connections section, you'll notice that all of the information has been populated, meaning that all we really need to do at this point is press the publish button. Once done, you'll see the Visual Studio output pane, upload the code and set the access control lists before a new browser window is opened and our page is displayed. And that's it, we're done. It's almost too easy, isn't it? But that's the great thing about Azure. We're empowering you to do amazing things with minimal effort. Anyway, let's jump back into the web app, create a deployment slot and then lock down authentication. So let's go ahead and create a new deployment slot so that we can begin working on version 2 of our site. We'll call our slot dev and then choose not to clone from the original. Finally, let's press OK to proceed. Now that will take a moment to build, but once done, let's go ahead and click into the new deployment slot. You'll notice that the console looks similar to the last, but what's different in this instance is that our slot has a new URL associated with it, and if we click onto it, we are redirected back to the blank template. Now in order to upload our development slot, we will again need to download a publishing profile. So let's go ahead and download from the top menu. Then, from back inside Visual Studio, I'm going to rename my website to Build a Company in a Day V2 and upload to the new slot, ensuring that I select the dev file from my downloads folder. As before, the website will open into the new URL, but we now have the option of swapping between development and production slots by toggling the swap button in the Azure Portal. Okay, so back into our main web app, I'm now going to enable Active Directory authentication. To do so, I will select Authentication, Authorization from the left-hand menu and then set App Service Authentication to on. Under Authentication Providers, I will move down to Azure Active Directory and then click to configure. In the management mode, I will select Express and then OK. Back Back in the main window, I will change the action to take when the request is not authenticated to log in with Azure Active Directory and then press save. So let's now test this out. If I click back into Overview from the left-hand menu and then onto our website URL, we should now be prompted to authenticate. Now obviously, because of cached credentials, I was prompted for authentication, but then passed through. So let's look at what happens if I try that again from an incognito window. Notice that not only am I asked for a username to proceed, but the customization from our earlier demo is also in effect. Okay, let's jump out of the portal and think about our next demo. Now, as I said earlier, Logic Apps are my favourite thing in the cloud. True serverless computing, simple workflows, and an abundance of connectors. These things will change the way you work, and I know that when you see what they can do, you'll fall in love with them too. We're going to build out a couple. The first will be used to automate our social media and push out a Twitter post whenever a new Azure blog is created. Let's get it done. So from our portal, I'm going to press the key combination G and R to display our resource groups. Then from here, select PaaS resources. Once inside, I'll move up to the menu bar and press the Add button before searching for a Logic app from within the marketplace. When a new blade opens, I'll simply press the Create button. Now in the configuration blade, you'll notice that we have very little to do. In fact, I'm just going to name our Logic app RSS feed and ensure that the subscription, resource group and location properties are correct. I'll also choose to enable log analytics before selecting to pin to dashboard and create to begin deployment. Now this should only take a few seconds to complete. Once deployed, let's go ahead and create a new blank Logic app. Then in the Logic App Designer, I'll go ahead and select the RSS connector. From here, let's select the trigger RSS when a new feed item is published, and then type in a URL for Microsoft.azure.com's blog into the dialog box. Once done, I'll go ahead and set an interval to 30 and leave the frequency as minute. With our RSS properties configured, let's go ahead and press the New Step button. Then we will select the Add an Action button to proceed. Once more, we are asked to choose an action. So in the connector search box, I'll type the word Twitter so that we can configure our social media posts. Now at this point you'll notice that the Twitter connector offers many more triggers than that of the RSS connector. However, all we want is a simple tweet to be sent, so let's go ahead and select the top trigger, Post a Tweet. Once selected, we're going to need to authenticate into our Twitter profile. So I'll go ahead and press the Sign In button, and then from there enter my Twitter handle and password before pressing Authorize. And you'll see that once authenticated, our connector properties box changes once more, this time prompting us to enter the tweet text. But here's the cool thing, look at what happens when we click inside the properties box. Because we've already established an RSS connector, dynamic content is returned, meaning that we can now simply click on what we would like to be tweeted from the RSS feed. Let me demonstrate. I'm going to select both the feed title and the primary feed link from the dynamic content pane and then head to the top of the menu bar and press the Run button. Now, proving that this works may be a little tricky. You see, we're at the mercy of the bloggers at Microsoft, meaning that we will only see a post after they create a blog. Anyway, to get an idea of what this is doing, let's head over to my personal feed. Now, I've been using Logic apps like this for months, and we'll notice the posts as we scroll down my timeline. Okay, with that done, let's discuss our next piece of the demo. Now, this next Logic app will be a little bit more complex. However, it also yields a higher business value. You see, what we're going to do here is build a social sentiment engine, one that will monitor our Twitter presence and report back on any negative tweets received. To do this, we're going to use cognitive services, a collection of APIs, SDKs, and tools that enable developers to build more personal computing experiences with applications that are more intelligent, engaging, and discoverable. And what company wouldn't want this? So let's jump back into the portal and make it happen. So once again, let's go into PaaS Resources resource group by pressing the key combination G and R. Now the first thing that we're going to do is configure the Text Analytics API, which is one of Microsoft's cognitive service offerings. To do so, we will simply click on the Add button at the top of the menu and then from the Marketplace search for Text Analytics API. When the new blade opens, we will simply click on the Create button to proceed. Now here's the impressive thing. For a service that will offer so much in terms of enrichment, look how little we actually have to configure. We simply need to provide a name, to which I will call our social sentiment, and then select our subscription, location and resource group, which in our case will be the existing resource group, PaaS Resources. I'm also going to have to choose a pricing tier. Now this ranges from thousands to millions of transactions per month. For the sake of our demo, I will choose the F0 or free tier. Finally, I will select the checkbox to pin to dashboard before pressing the Create button. And that's it. After a few seconds, the service is ready. All I need to do now is copy the endpoint URL from the main blade into Notepad and then navigate to keys under Resource Management and copy the name and the key 1. Next, let's open a new tab and head over to Power BI. From here, we'll sign into our account and then under Workspace create a new streaming dataset. To do this, I will navigate to Workspaces from the left-hand menu and then select Create App Workspace. I will then name my workspace Build a Company in a Day and ensure that my account is added as the workspace member. Once done, let's press Save. When the workspace has been created, I will expand from the left-hand menu and then click on Datasets. Now you'll notice that we have no datasets, so let's go ahead and build one out. To do this, simply click Skip for now on the main page and then New, Create Streaming Dataset. In the new pane that opens, let's go ahead and select APIs as the source of the data and then click Next. In the dataset name, we will type Build a Company in a Day stream, and then in the values from the stream, we will type the following key pairs. Tweet text, which will be text, location as text, created at as date time, followers as number, and sentiment score as number. Finally, we will ensure that we have set historic data analysis to the on position and press the Create button. Now let's head back into our Azure Portal and create our logic app. So from the dashboard, I will once again type the key combination G and R and then select the PaaS Resources resource group. From there, I will click on the Add button on the top of the menu and search once more for a logic app. We will name the logic app Social Sentiment and ensure that it's in the right subscription, resource group and location before selecting to turn on Log Analytics, pin to dashboard and press Create. Once created, we will select a blank logic app from the Logic Apps Designer and then add the Twitter connector. Now, because we've already authenticated to the connector, it will take us directly through to the triggers. Let's go ahead and select when a new tweet is posted and search for the hashtag build a company in a day. We will change the interval to 30 and the frequency to second before pressing the New Step button and selecting Add an Action. In the Search for all connectors and actions search box, let's go ahead and type Text Analytics, and then once found, select the Text Analytics connector. In the three options returned, let's choose Text Analytics Detect Sentiment and then Social Sentiment for the connection name. The account key will be key 1 that we copied into Notepad, and the site URL will be the endpoint. Once done, let's go ahead and press the Create button. Now once the connector is configured, we will click inside the Text to Analyze box and then select Tweet Text from the Dynamic Content blade. I will also show advanced options and select EN as the language. Once again, I will choose to add a new step and then select Add an Action. From here I will search for the Text Analytics connector, but this time choose Key Phrases and Tweet Text from the Dynamic Content blade. Moving on, I will add a new step and then select Add an Action. From here I will search for Power BI and then in the Trigger section select Add Rows to a dataset. Now I will need to sign into the service, so let's go ahead and click on the Sign In button, and then from here I will enter my logon credentials to authenticate. Once authenticated, I will be presented with 3 configuration parameters, and I will need to select my workspace, dataset and table. For the workspace, I will select the Build a Company in a Day from the drop-down menu. Then for the dataset, I will select the Build a Company in a Day stream that we created earlier. Finally, in the table, I will select real-time data from the drop-down menu, which as you can see, expands the parameters to include the fields that were specified earlier. Now all we're going to do here is dictate the information that we will pass back into Power BI. That will help us visualize our followers' sentiment. Let's go ahead and configure the following. For tweet text, I will select tweet text. For location, I will select location, created at, followers will be the followers count, and sentiment score will be score. Now we won't see this visualized data until later in the presentation when we create our dashboard, but when we activate our Logic app in a moment, any tweets we received will be sent to Power BI via the streaming dataset that we created earlier and therefore ready for visualization when we get to it. For now, I want to create a new action that will notify me of any negative tweets received. So let's go ahead and click on the New Step button, but this time select Add a Condition. In the Condition Parameters box, we'll select Score and then select Is Less Than and finally 0.4 as the value. Then, in the If True Parameters section, let's go ahead and select Add an Action. From here, let's search for Office 365 Outlook and then send an email for the trigger. Again, because this is a new connector, we will need to authenticate. So I will click on the Sign In button and enter my corp credentials. Once authenticated, I will go ahead and send an email to azuredan@buildacompanyinaday.onmicrosoft.com with the subject title Negative Tweet Detected. Then, in the body, I will type the following. Name tweeted a negative tweet. The tweet reads, tweeted text. They have followers count, followers. Please investigate. With that done, all that's left for us to do is test. So let's go ahead and hit Run on the top menu bar and then create a negative tweet. As you can see, it doesn't take long to appear in our mailbox, proving that the Logic app is working. So with that done, let's jump back into the slides and discuss how we're going to visualize. Okay, so let's spend a moment talking about data. Now we generate a lot of data. In fact, it's currently estimated that we generate about 2.5 quintillion bytes of data every day. And that number continues to grow. In fact, if you look at the research, 90% of the data in the world has been generated within the last 2 years. And that includes the 3.5 million text messages, the 456,000 tweets, and the 47,000 Instagram posts that we generate every minute. That's right, every minute. It's not difficult to see data is big business, and being able to capture, process and act upon it is critical to our continued success. But where will data come from? How will it evolve? Well, one of the platforms that will generate this data will be IoT, or the Internet of Things. Today we have over 8.5 billion devices, but by 2020 that number is estimated to rise well into 20 billion. This will be connected cities, connected cars, connected agriculture, even connected humans. It's true. I'm already cloud connected with a device that monitors my blood glucose, enables both my medical team and family to check on my well-being. It's an amazing time for technology, and when used right, capable of incredible things. Now, Microsoft offer an abundance of data services. These include warehousing technologies that store the data, factories that process the data, and then tools such as bots and Power BI to visualize the data. In our demo, we are going to want to visualize the stream of data that was fed into Power BI from our Logic app. So let's jump back into our demo and see how it's done. So from Power BI, let's go ahead and click on Create Report from the Build a Company in a Day stream to open a new report window. From here you will notice a blank canvas, but in the far right under real-time data you'll see the parameters that were configured earlier. Now the first thing that I want to see is what's been tweeted. To do this, I'll simply click on the tweet text from the right hand menu, which in turn will open a table containing our tweets in the center window. Next, we will gauge the overall satisfaction of our followers by dragging the sentiment score over to the main window. Now I want to make this a little more visually appealing, so I will go ahead and change the visualization to gauge. Finally, I want to find out where the tweets were made, and I can do this by adding location and changing the visualization to map. And that's really all there is to it. We can manipulate the data and visualizations to meet our needs and then share the dashboards with those who have a common interest in the data. One of the more exciting ways to interact with our data is via bot technologies. And over the past few years, we've really seen an explosive growth in their popularity. Now, to really understand why, we need to think about consumers and how they interact through mobile and online services. In the past, customers were happy to search the internet, visit websites and navigate through menu systems until they found what they wanted. But today, in a world that moves at the speed of cloud, this is simply no longer the case. Most will be using messaging technologies such as Skype or Facebook Messenger, and companies are looking at ways to tap into that captured audience through these services. Think about the times that you've ordered pizza. Now in the past that would have been a phone call, then as technology evolved, through a website. And while that was fast, it still meant having to talk to a person or navigate through a site to select the pizza of choice. Today things are different. Today pizza can be ordered through Twitter, Facebook, or to the delight of my son through a smart speaker by simply asking for it to feed me. And that really emphasises the power of bots. You see, it's no longer about the person having to understand the machine. It's about the machine understanding the person. And simple conversational interactions are putting the end user firmly in the driving seat. Now, we won't be building a pizza bot today, but we will be building a super easy chatbot using some predefined tooling that we can then connect into our website. Let's jump back into the portal and take a look. So before we configure anything in the Azure Portal, I'm going to open up a new tab and head on over to qnamaker.ai. Now this site would allow us to quickly configure a new bot, and once I've signed in, I will head up to the main menu bar on the top of the screen and select Create a New Service. This will open up a new page and we'll start by naming our service Build a Bot. Next, we have three options to choose from. We can populate the payload of the bot by consuming an existing FAQ page by simply pointing to its URL. Failing that, we can upload an existing FAQ by supplying the site with a tab separated file, PDF, Word document or spreadsheet. Finally, we can choose to create the content from scratch by building our question and answer pairs directly. I'm going to go ahead and select to upload a file, and then from the C Demos AzureBot folder, I'll select the azurebot.tsv file. Now that should be about 33 kilobytes in size, and once uploaded, I will scroll down to the bottom of the page and click the Create button. After a few seconds, our knowledge base will load, and from here you will see 70 question and answer pairs. Now, I've created this bot to answer questions related to Azure, giving a simple explanation and then pointing to docs.microsoft.com for further reading. To test, let's move to the left-hand menu and click on the test link. The page will once again change, and you will see our chatbot presented along with its configured welcome message. From here, I will test the bot by asking it to tell me about virtual machines. As you can see, not only is a simple explanation returned, we now have a link to the document repository for further study. Okay, our bot is ready. It's really that easy. So let's go ahead and get it published. To do so, I will move up to the top of the page and click on the publish link. The page will change once more and invite us to review our changes. But I'm happy with what we have, so let's click on the publish button to proceed. Now with our services published, we are provided with some sample HTTP request code. This can be used as a foundation to start building our chatbot front end. However, if we head back into the Azure portal, I'm going to show you an even easier way to start interacting with our bot service. So from the portal, let's click on Create a Resource from the left hand menu, and then in the marketplace I will search for Web App Bot. From here, I will press the Create button, and then in the new blade that opens, enter a bot name, Build a Company in a Day, Demo Chatbot. Next, I'll confirm that I'm happy with the subscription being used and select the PAS Resources resource group, ensuring that we're in the West Europe location. For the pricing tier, I will select F0. This is the free tier and will give me access to thousands of messages, more than enough for our demo. For the app name, we will leave it as is. Then in the bot template, I will go ahead and select question and answer before pressing create. Now for the app service plan, I'm going to use the plan that we created earlier. We have more than enough capacity to run both our website and our chatbot, so there's no need to create another. A storage account will need to be configured to store our bot state, and I'm happy with the defaults here, so I'll move on. For application insights, I will ensure that it's set to on and set my location to West Europe. Finally, I'm happy to auto create the app ID and password, so I will choose to pin to dashboard and press the create button. Now this will take a few moments to complete, so let's pause the video and return once done. Okay, with our web app bot provisioned, we just need to connect it into our bot service. To do so, I will click on Application Settings under App Service Settings and then add the Knowledge Base ID and subscription key from Q&A Maker. With that done, let's go ahead and press Save. Now at this point, we're in a position to add our chatbot into our website. To do so, I'm going to click on Channels from the left-hand menu. Now just make note of all of the connectors that you have available to you. You can connect into websites, Skype, Teams, Facebook, and many more. What we want to do is get the embedded code for our bot, and I will do this by clicking on the Get Bot Embed Codes. In the prompt, we'll click on the Open the Web Chat Configuration page, and then in the new window that opens, copy the embed code into Notepad. At this point, you will notice that we need to enter a secret. To do this, let's go back into the channels page and copy the key. Now that we have our key, let's paste that back into Notepad and then make sure that our iframe is set to maximum width and height. With that done, we'll copy the whole line and update our web page. To do this, let's navigate back to the Azure portal and into our website. Now remember earlier we spoke about the online editor? Well, let's now use this to update our page. So from under the development tools, I'm going to select App Service Editor and then Go in the main window that opens a new tab into our browser. In the editor window, I will click on the index.html file and then paste the code underneath line 25. Now this will automatically update, so let's navigate back into Azure and click on the URL to open our website and test the new code. As you can see, after a page refresh, we now have a chat window present on the right hand side, and if I type virtual machines, you'll see that we're presented with a summary and a link to the virtual machines documentation on docs.microsoft.com. So I want to spend a little more time talking about the other cognitive services, and in particular, the Vision API. You see, with this service, we can distill actionable information from images, text, handwriting, and even video. And if we think about the practical applications, it could be used to determine mature content, locate faces, or even categorize the context of an image, such as identifying a celebrity or landmark. If you look at services such as Facebook, they are already using vision technologies. For example, when we upload images, the service will usually identify friends and associates and then offer to tag on our behalf. Or perhaps the technology could be used by police and enforcement agencies using the vast network of CCTV cameras in our cities to help identify suspicious behaviour and petty crime. Let's jump into a demo and look at this in action. I have already built the front-end code, so all we are going to need to do is create the Vision API service in Azure. So back into our portal, and from the left-hand menu, I will click on the plus sign to open the Azure Marketplace. From here I will search for the Face API, and then when a new blade opens, simply press the Create button. In the new blade, I will type Build a Company in a Day Vision for our name, and then ensure that I'm happy with the subscription and location. For the pricing, I will go ahead and select F0, which is the free tier, offering face detection, identification, verification, grouping and searching for up to 20 calls per minute and 30,000 calls per month. Next, I will select the PAS Resources resource group and confirm that I have both read and understood the notice on screen. Once done, I will select Pin to Dashboard and then press Create. After a few seconds, the service will be deployed. Now I want to grab two things here, the endpoint URL under Essentials and then the access key by clicking on the link Show Access Keys, both of which I'll copy into Notepad. Now, as I said previously, our code has already been created, and I believe that it's originated from a piece of work that was originally created by Scott Hanselman, so props to him. Anyway, from Visual Studio, I will navigate to the main window.xaml.cs and move down to the section named Face Service Client, whereby I will replace key 1 with the key that we previously copied into Notepad. We'll also need to verify that the endpoint URL matches the one that is defined in our script. With that done, let's move up to the top menu bar and press Start to Test. As we can see, our program opens, and if we click on the Browse button, we can navigate to the CS Vision folder and select the azuredan.jpg image. From here we can see that the Vision API service has detected my face, and if I move the mouse over the square, I'm presented with the analysis of the image and given my sex, age, emotion and feature metadata. Again, I invite you to investigate further, because what we are achieving with cognitive services is simply incredible. Head over to our cognitive services page and play with the sample code and demo projects. Okay, let's move on to our last section and discuss security and monitoring. Now, this is usually a hot topic when I meet people, and we must address a reoccurring question. Is the cloud safe? Yes. The short answer is yes. In my opinion, the cloud is by far the safest place to store and run resources. And I get it. It's scary moving your data to a remote server where it's not under your direct control. But the reality is, cloud providers such as Microsoft have spent billions of dollars on building these fortified data centers, and your data is encrypted both at rest and in transit using either client-side or server-side encryption technologies. What's more, your virtual machines can be protected using Azure Disk Encryption, utilising technologies such as BitLocker or Linux DM Crypt to protect both operating system and data disks with full volume encryption. Then on top of this, we have redundancy, with distribution of replica pairs separated by hundreds of miles. What this means is that they are not susceptible to the same regional disasters, so things like floods, fires and outages are contained. Let's take a closer look. Now this could be a day-long discussion in its own right, so let me do my best to summarise. The fact is, security and privacy are built right into the Azure platform and realised through a defence-in-depth model. Starting at the physical layer, we employ 24/7 security personnel to protect our facilities with cameras, alarms, barriers, fencing and biometrics. Then, secured by design, our infrastructure ring employs the latest in operational security controls and the most comprehensive set of compliance certifications than that of any other cloud provider. Next, we have the network layer, with isolated virtual networks, access control lists, and a myriad of security appliances. Finally, the VM layer, with encryption, access control policies, malware screening, and protection. The fact is, security should always be top of mind, but rest assured we've got it covered. Now, one of the tools that help you realise our commitment to security is the Azure Security Center. ASC is enabled with your Azure subscription and helps you protect, detect and respond to threats with increased visibility and control over your Azure resources. It provides integrated security monitoring, policy management and helps detect threats that might otherwise go unnoticed. What's more, it works with a broad ecosystem of native and partner security solutions. Now the service is available in two tiers, the free tier which provides visibility into the security of your resources, policies and security recommendation, and then the standard tier which adds advanced threat capabilities including threat intelligence, behavioural analysis and threat attribution. ASC also employs role-based access control and provides built-in roles that can be assigned to users, groups and services. What's more, your environment is broken down by compute, networking, storage, data and applications, with each resource type employing its own metrics and indicators to warn of potential breaches and vulnerabilities. Let's jump back into the portal and take a look. So let's begin by clicking into the Security Center from the left-hand menu. Now if this is the first time that you've clicked onto the service, it will take a few minutes to get ready. So we'll pause the video and return once complete. Once done, you'll notice a message at the top of the screen stating that our security experience may be limited. This is because we're using the basic SKU. Fortunately, we can get a 60-day free trial of the more advanced service, so let's go ahead and click on the message to learn more. As we can see, the standard tier will add advanced threat detection capability, which is definitely something that we'll want to investigate. So let's click onto our subscription to continue. In a new window that opens, notice the advanced features. Features such as just-in-time, VM access, adaptive application controls, and both network and VM threat detection. Let's go ahead and select standard, followed by save to continue. Okay, so with our service updated, let's take a whistle-stop tour of the service. To begin with, we have the overview screen. This provides an at-a-glance view of any security recommendations along with alerts and prevention items related to compute, networking, storage, data and applications. If I click on recommendations, we'll see a list of detected concerns and mitigation steps needed to make our environment more secure. For example, we can see that on ADVM, endpoint protection has not been installed and vulnerability assessment solutions are missing on our virtual machines. Let's take a look at how we can resolve these issues. To begin with, I will click on the endpoint protection not installed on the Azure VM. Notice how a new blade opens, identifying the affected VM and a button on the top of the screen that offers to mitigate the issue by installing a solution. If I press the Install on one VM button, I'm taken to a new screen where I can choose the service endpoint provider, in this instance Microsoft Anti-Malware. In the new blade that opens, I will press Create and then accept the defaults before pressing OK to continue. As we can see, this then starts endpoint protection installation on the affected virtual machine. Back into our recommendations, I'm going to select Add Vulnerability Assessment Solution, which again will open a new blade. Now notice that both ADVM and VM1 are missing the tool, so I will select both and then choose to install on 2 VMs to continue. In the new blade that opens, I have the option of creating a new solution or using an existing one. In this instance, I will choose Create New, and from here we're presented with a partner solution that I will click into. Now you will notice a new blade that opens, and once again I can configure the solution to mitigate the risk on my VMs. For now, I will cancel by heading back into the main page of the Security Center. So back into the main window, I'm going to click onto the Compute tile, which is displaying a red warning bar. As the page changes focus to the compute specific issues, I will click onto VMs and computers from the main menu. From here, I get a breakdown of the security assessment in tabular form, and as we can see, only one of my VMs is currently being monitored. Let's click on VM1 to find out more. In a new blade that opens, we're able to see the reason that VM1 is not being monitored, and it's because the agent has not been installed. By clicking onto the link VM1, we are taken into the management window of the VM. From here I can see that the VM is running, so let's try and get this protected. To do so, we will once again click into the Security Center from the left hand menu. If I click onto recommendations once more, I'm looking for a notification to enable VM agent. As we can see, this isn't the case, which means it's not installing in the background. We may have to therefore install this manually. Fortunately, this is super easy to do via the MSI, which can be found in the following location. Now we can also see that we need to enable an NSG in the ADVM virtual machine as well as the production subnet. You'll remember earlier in the course that we stated that the NSG was a software firewall that helped control the flow of information to our resources. Let's go ahead and get this resolved. To do so, I will click on the warning for ADVM and then onto the VM in the new blade that opens. We can see that we have 2 NSGs configured, one for VM1 and another for VM2. Let's go ahead and create one for ADVM. To do so, I will click on the Create New button. I will name the NSG ADVM and then on the inbound rules add a new rule for TCP port 3389 by selecting the RDP service and pressing the OK button followed by OK. Back into the Security Center and we can see that our security threats are beginning to get resolved. Now for the sake of time, I won't continue working through the list, but I hope that I've been able to demonstrate how easy Azure Security Center makes it to manage the security of your resources. One thing that I do want to touch on is something called just-in-time VM access. You see, brute force attacks commonly target management ports to gain access to a VM. If successful, an attacker can take control and establish a foothold in your environment. One way to reduce exposure is to limit the amount of time that a port is open. When just-in-time is enabled, Security Center locks down inbound traffic to your Azure VMs by creating an NSG rule. When a user requests access to a VM, Security Center checks that the user has the necessary role-based access control permissions and then automatically configures the network security groups to allow inbound traffic to the management ports for a specified amount of time. After the time has expired, Security Center restores the NSG to their previous state. Let's take a look at implementing the solution. To do so, I will click on Just-in-Time VM Access in the left-hand menu of Security Center. Then, in the new blade that opens, click on the Recommended tab and select both ADVM and VM1. In the new blade that opens, we can see the ports that will be configured and the time range that they will be open. Now this can be configured to your individual needs, but for our demo, we will go ahead and select the defaults by pressing save. With just in time configured, let's click on the configured tab and request access for VM1. In the new blade that opens, I will turn port 3389 to the on position and then adjust the time range slider to 1 hour. Finally, I will click the Open Ports button to continue. After a few moments, notice the just-in-time window displays that Azure Dan is now active. Let's test this out by connecting into the VM. From the left-hand menu, I will click onto the Virtual Machine tab and then select VM1. In the VM1 window, I will copy the public IP address and then open Remote Desktop to connect. As you can see, the session is successful. Okay, so let's move on to our last demo, Privileged Identity Management. Privileged Identity Management enables organizations to minimize the number of people who have access to secure information or resources, thus reducing the chance of malicious activity or accidental release of sensitive information. Azure AD Privileged Identity Management helps your organization by enabling on-demand, just-in-time administrative access to online services such as Office 365, Intune and Azure. Let's look at implementing the solution. To do so, I will navigate up to All Services and then search for Privileged Identity Management, choosing to favorite so that it appends to my left-hand menu in the process. In the new window that opens, I will select Azure AD Directory Roles under the Management heading. In the new blade, I will select Verify My Identity and then follow the prompts to set up multi-factor authentication using my phone. When authentication is complete, I will then press Done to return to the Azure Portal and then click Sign Up to detect privileged role assignments. When the blade refreshes, I will select Roles from the left-hand menu. From here, I will click on Justin's account under the Global Administrator to make him eligible for Privileged Identity Management rather than permanent. Once done, I will close the blade. Now in the main Azure AD Directory Roles blade, I will select Settings under Manage. From here, I will click Roles, then Global Administrator so that I can move the maximum activation duration slider to 2 hours and enable email notifications. Finally, I will click Save and then navigate back into Azure AD to verify that Justin has been reverted back to a user and no longer a global admin. Okay, so from an incognito window, I will sign into Azure as Justin and then access Privileged Identity Management from the All Services menu. In the blade that opens, I will click on the tab My Roles and then Global Administrator. From here, I will verify my identity by once again responding to phone verification. Once done, I will be returned to the Azure Portal and the Global Administrator role Activation Details blade. From here, I will click the Activate button and then type User Management in the reason box before pressing the OK button. Once activated, make note of the expiration time, which will be 2 hours from now. To verify that privileged identity management has been successful, I will minimize the incognito window and back into my Azure Portal session. From here, I will click on the Azure Active Directory and then Users before selecting Justin's account. If I then click on Directory Role, you will see that Justin has been elevated back to a global administrator and privileged identity management has been successful in helping to lock down our resources. With that, let's jump back into the portal and wrap up our session. Well guys, I hope that you found this session to be both enjoyable and informative. And it's my hope that we have sowed the seeds of possibility and inspired you to go off and continue your Azure journey. We started off by looking at the components of the cloud and really understanding the Microsoft proposition. Then we looked at some of the more common infrastructure components, building our networks, VMs and containers. Then we looked at authentication and identity before shifting focus and exploring DevTest environments and BCDR solutions. From there, we began to explore platform components and touched on a world of serverless computing. Finally, we looked at the security and monitoring tools available in Microsoft Azure and the steps we employ to ensure that your experience is safe, reliable, and consistent. If we look back at our service chart, we have barely scratched the surface, leaving you with a technical treasure hunt to go off and explore. Remember, you can sign up for a free trial at any time, and if you have questions, then feel free to reach out to me because I'm always happy to hear from you. We've covered so much and in such a short period of time, leaving me with just one question: what could you build in a day?